Hello dear students, welcome back to BYJU'S Exam Prep. Now under data structures and algorithms, we are talking about a concept called how to think recursively. Under that, we already started this topic which is called recurrence relations. Yesterday we learned how to write recurrence relations for some problems. Today we'll continue the same under this recurrence relations part 2. Okay. See, this topic is not just restricted to data structures and algorithms. This particular topic you can also see in discrete mathematics, even in C programming, sometimes in theory of computation also. Okay. So this is one of the important topic, my dear friends. Now before starting with the topic, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and my qualifications are MTech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. I worked in all prestigious GATE institutes earlier. From past 1 year, I am working with BYJU'S. And from past 1 year, we are working on a project which is recorded GATE content. It is first of its kind and unique content. We created visualized animated content from past 1 year. Many teams were involved. Under BYJU'S Exam Prep app, you can find this under the category Learn with Video Lessons. I already recorded the following topics. Hi Tanmayi, very good evening. Discrete mathematics, algorithms, engineering mathematics, C programming and data structures. I separated C programming and data structures so that the concepts can be discussed in more detailed manner. Okay. So this is about me, my dear friends. So let me start with the story which we started yesterday. That is recurrence relations. Okay. So I given this problem. Hope some of you tried this problem. So let me continue with this particular problem. Let an be the nth term of a geometric sequence. Write recurrence relation for an. See, you all know what is this geometric sequence. See, geometric sequence or geometric progression are one and the same. Okay. So you can call geometric progression or geometric sequence. What is geometric progression? We have first term. Every time you multiply with a common term, we call it as common ratio. We call it as what? Common ratio. So next term is AR. Again you multiply with R, that is AR square. Again you multiply with R, that is AR cube, and so on. Now what is nth term of this geometric progression? The nth term is given by the formula A into R power n minus 1. A into R power n minus 1. See, recurrence relation means it is not solving the problem. Please remember, this is the misconception for many people. Whenever they give recurrence relation, they want to solve the problem. We don't solve the problem, sir. Recurrence relation means writing problem in terms of subproblem. And this is one of the important problem solving technique. Not only for GATE, if you go for any competitive examination, the idea of recursion plays very, very, very important role, my dear friends. Even in GATE, you can see many questions based on recurrences or recursions or recursive algorithms. Almost 60% of your algorithm course is based on recursion. Okay, you directly discuss recursions, recurrence relations, recursive algorithms. Divide and conquer algorithm is based on recursion. Dynamic programming is based on recursion. So this is one of the important topic, my dear friends. Okay, got it. Now I want to write this nth term in terms of previous terms. Previous terms means maybe n minus 1 terms or n minus 2 terms. Okay, see, if you observe this is nth term of arithmetic progression. Okay, now what is n minus 1th term, sir? According to this formula, it is A into R power n minus 2. Now, how can you write the nth term in terms of n minus 1 term? So we can write nth term in terms of n minus 1th term like See, if you multiply this fellow with r, you're going to get nth term. That is a r power n minus 2 multiplied with r will give you nth term. So this is simply Tn minus 1 into r, which is Tn. Okay, here I used Tn, this fellow used An, my dear friends. See, we need to understand the notation. Sometimes we use a regular notation, but in examination they may give different notation. Don't be panic. Don't run away. Am I clear? It happens. Okay, because we generally use Tn as nth term, but here this fellow used An. Okay, so what happens? This instead of t, wherever t is there, you can write An, or after completing solution, you just write in terms of An. An is equal to An minus 1 into r. So this is your formula, my dear friend. So this is how we can express the nth term of a geometric sequence in terms of the previous terms. Recurrence relation means expressing a problem in terms of subproblems. Expressing a problem in terms of subproblems. That you remember. Don't solve the problem. You are not solving the problem. Recurrence does not mean solving a problem. We are just expressing problem in terms of smaller versions. Express the problem in terms of smaller version of same problem. That is the idea, my dear friends. Okay. So this is the recurrence relation, but whenever you write recurrence relation, we should keep one thing in mind. What is it? Base condition. Because you are expressing big problem in terms of smaller problem. Again, that subproblem or smaller problem is expressed in terms of some more smaller problem. So this will continue forever and ever and forever if you don't stop it. So the stopping condition is one of the important thing when you talk about recursion, my dear friends. If you don't stop, you will get into infinite loop. Okay. So whenever you talk about recursion, what we need to do? We need to put stopping condition. Base condition we call it. So for this, what should be the stopping condition, sir? An means nth term. And what is nth term? This is like, nth term means we are starting from first term, second term like that. Then what is first term here? First term is A. This is first term. A is first term. A into R is second term like that. This An minus, that is An means nth term of the geometric progression, my dear friends. And this is your complete recurrence formula or recurrence relation. Okay. So this recurrence formula or recurrence relation can be used to write recursive algorithms, my dear friends. Or you can write recursive functions if you are writing a particular programming. That's it. Am I clear? See, whether it is a programming language or whether it is a algorithm we are writing or it is in mathematics, the idea is we are expressing problem in terms of subproblem. Don't solve the problem. See, when you're doing recurrences, please remember, don't solve the problem. Just express problem in terms of smaller versions of same problem. That is the idea to be noted. Am I clear? So whenever you take recurrences, please remember this, my dear friends. What? Express problem in terms of subproblem. So let us take one more problem. Next interesting problem. If you have any doubts, you can write comment. Later on when you are watching this, you can write comments, my dear friends, under comment session. Okay, you can always do that. Am I clear? Next problem. A person climbed n steps such that he can skip at most one step at a time. This is a information given to you. A person can climb n steps in such a way that he can skip at most one step. Write recurrence relation for number of ways to climb n steps. How many ways he can climb n steps? You need to write a recurrence relation for that. Okay. So let us see this. So here we are having this particular steps. Okay, let us assume here, of course, 1, 2, 3, 4, 5, 6 steps are there, but let us understand this as n steps. A person is there. Suppose this is a person. He wants to climb these n steps. Okay. How many ways he can climb n steps? You not write the answer, sir. You have to express this number of ways he can climb n steps in terms of number of ways he can climb less than n steps. It may be n minus 1, n minus 2. You can use more than one of the sub-problems, sir. You just need to express the problem in terms of one or more sub-problems. Same sub-problems. That is the idea. Okay, first let us understand generally. Suppose he is having only one step. Here the person is here, only one step is there. How many ways he can climb? Here the condition is there. The condition is very interesting. He can skip at most one step. He can skip at most one step. That is a condition. With that condition, how many ways he can climb one step? See, when one step is there, even he can skip the step. How can he skip, sir? He'll jump, he'll fall on the same step only. Because only one step is there. He can climb this in only one way. That is, suppose if I use this, let us write some terminology like, AN as number of ways person can climb, number of ways person can climb n step with this condition, okay, with given condition. I'm just writing with condition because we know the condition. He can skip at most one step at a time, okay, such that he can skip at most one step. If you want, you can write full condition such that he can skip at most one step. Okay, he can skip at most one step. So if I say AN is this, number of ways he can climb n steps, then what will be A1, sir? What will be A1? The number of ways he can climb one step. What will be that? If anyone watching can please answer that. It would be interesting if you start answering, my dear friends. One step is there. How many ways he can climb one step? Okay, one way he can climb one step. Only one step is there. Even he can skip that because there is no other choice for him. He has to climb one step only. One way he can climb. Now suppose if this person is having two steps, same person, with this condition, how many ways he can climb two steps? How many ways he can climb two steps? With the condition that he can skip. See, it's not like he has to skip. No, he can skip. वो एक step छोड़ सकता है. उसको छोड़ना ही नहीं, ऐसा नहीं है. He can skip one step. That is the condition. He can. Okay? It is not like he has to skip. No, he can skip one step. So what he can do is he can climb like this. Without skipping, gentleman की तरह एक step के बाद एक step चढ़ेगा. एक way है. This is one way he can climb two steps. और एक क्या होगा? What is the other way he can do this? Oh, very good, Bikram Shahi. Good. One ways. Yeah, can you tell me how many ways he can climb two steps? Actually, there is a small delay here in YouTube. So, if you are answering, I'll wait for you. Otherwise, I'll continue. Okay? Bikram Shahi or anyone? Okay, fine. So how many ways he can climb? Two steps. This is one way. What is the other way? He can skip the step also. No, this is another way he can climb. This is one way. So 1 plus 1, 2 ways he can climb. That is if two steps are there. If two steps are there, how many ways he can climb? Directly without skipping he can climb, or directly he skips and he directly. Very good, Bikram Sahi. Very good. Wonderful. Two ways he can climb. A very simple mathematics, my dear friends. Okay. So you can try this. Before I complete my solution with recurrence relation, you please try if three steps are there, how many ways you can climb. If you are seeing this, just answer this. I'll just start my recurrence relation. Am I clear? So this you please try, sir. If three steps are there, how many ways? See here, this is not recurrence relation. I am just taking a method like one step है तो कैसे करेंगे? General method में solve कर रहे हैं. Here I am not writing any recurrence relation. Now I start writing recurrence relation. Now I start writing recurrence relation. Okay. So let us see the recurrence relation for this. So we are having total n steps. Total कितने steps है? N steps है. So I just use this an for number of ways to climb. I am not writing complete statement, simple statement I am writing. Number of ways to climb, or let me write number of ways, or this way we'll write it. Number of ways to climb n steps. Okay, with the condition such that you can skip at most one step. That condition is always there. So I say with condition. So you all know the condition. No, I'm not writing condition. I'm just saying with condition. Now an minus 1 क्या होगा? Number of ways he can climb n minus 1 steps with the condition. Condition means he can skip at most one step. an minus 2 क्या होगा? Number of ways he can climb n minus 2 steps with the condition. Condition means he can skip at most one step. Okay. Now देखिए, see, this is actually the process of recursive thinking. How to think recursively, I am saying here. This is how we should see problem in terms of sub problems. Am I clear? इससे पहले हम जो किए थे, this is not recursive thinking. It is just एक step है तो कैसे? We are trying to see all possibilities and giving the answer. This is not recursive thinking. Now what I am saying is recursive thinking. अब जो मैं बोलने जा रहा हूं वो है recursive thinking. अभी देखिए, the person is here. ये बंदा इधर है. This person इधर खड़ा हुआ है. He need to take total n steps. n step चढ़ना है उसको. How he can start? वो कैसे शुरू कर सकता है? How he can start? Please try to understand. This is the most important point. ये जो प्रोसेस जो बताने जा रहा हूं, this is the heart of recursion. ये आप समझ गए तो recursion part would be very very easy for you. Am I clear? अब देखेंगे ध्यान से. अभी this person is here. I am not asking how he can take all n steps. I am just asking you how he can start. वो कैसे शुरू कर सकता है? How he can start? Two possibilities है. Because इधर condition क्या है? He can skip at most one step. He can skip at most one step है. एक step छोड़ सकता है. See, it is not like he has to skip one step. या तो छोड़ सकता है without leaving the step also शुरू कर सकते हैं. So he is having two steps. The first possibility is not skipping the step. Okay? Do not skip the step. ये step जो है skip नहीं करेगा ये. यानी he starts like this. He start like this. यानी एक step लेके remaining problem solve करता है. Am I clear? एक step लेके remaining problem solve करता है. Now here if you see, this totality is an. That is number of ways he can climb n steps. But after taking one step, what is the remaining problem? Sub problem क्या बचा है? Remaining sub problem क्या बचा है? After taking one step, he need to climb how many steps? और कितना steps चढ़ना है? How many steps he need to take more? Remaining n minus 1 steps. Again with the same condition. He can skip the step or he cannot skip the step. Okay? Either he can skip or he cannot skip and he can continue. But how he do the remaining thing, I am not solving. I am just saying he need to do n minus 1 work. That is, he need to do a n minus 1 work. So if he do not skip the step, how many ways he can do it? One way में कर सकता है. बाद में कितना काम बचा है? How much work is remaining? He need to climb n minus 1 steps with the condition. He need to climb n minus 1 steps with the condition. What is the condition? He can skip at most one step. He can skip at most one step. So if it happens, this do not skip the step can happen in one way, followed by what is the remaining work? He need to take remaining n minus 1 steps. If he do not skip the step, अगर वो step को skip नहीं करता है तो, अगर वो step को skip नहीं करता है तो, suppose he skip the step. See, he can start like what? He do not skip the step, या तो he can skip the step. ऐसा भी शुरू कर सकता है, because he is at the bottom. He need to take n steps. How he can start? विदाउट स्किपिंग द स्टेप स्टार्ट कर सकता है या विथ स्किपिंग द स्टेप स्टार्ट कर सकता है. दैट इज दिस इज हाउ ही कैन स्टार्ट. दिस इज द सेकंड वे ही कैन स्टार्ट दिस. स्टार्टिंग से कैसे शुरू कर सकता है? स्टार्टिंग से ही स्किप करके शुरू कर सकता है. विदाउट स्किपिंग द स्टेप शुरू करे तो ये सॉल्यूशन है. विथ स्किपिंग द स्टेप शुरू करे तो हाउ मेनी वेज दिस कैन बी डन? दिस कैन बी डन इन वन वे. फॉलोड बाय दैट अभी रिमेनिंग वर्क क्या बचा है? व्हाट इज द रिमेनिंग वर्क ही इज हैविंग? कितना वर्क बचा है इसके लिए? व्हाट इज द रिमेनिंग वर्क ही इज हैविंग? ही नीड टू टेक हाउ मेनी मोर स्टेप्स? और कितना स्टेप्स लेना पड़ेगा उसको? n-2 स्टेप्स. बिकॉज 2 स्टेप्स हो गए ना, अभी कितने भी स्टेप्स बचा है? n-2 स्टेप्स. देखो हाउ ही टेक्स रिमेनिंग n-2 स्टेप्स यू आर नॉट टॉकिंग. He takes remaining n-2 steps with the same condition. What is the condition? He can skip the step or he cannot skip the step. That is, he can skip at most one step. He can skip at most one step. So that's it, an-2. Therefore, solution क्या होगा इस problem का? an will be, that is number of ways he can climb n step is either this way or this way. So for this way, what is the answer? 1 into an-1, that is an-1. Or, because either that way or this way he can start. He cannot do combination way, no? He cannot stay here, no, in between. Am I clear? So this is exclusive. Am I clear? Because this is exclusive OR. Either he can do this or he can do this. So this plus this will be the answer. So this is an-1, and what is this? 1 into an-2 is an-2. And that is the recurrence relation, my dear friends. That is the recurrence relation. Okay? Okay, let me write in a box. Let us keep it safe. ये बच गया हमारा solution. Oh, very good, Bikram Shah. Wonderful. Okay, because if you continuously answer, I'll give you time, sir. Okay, otherwise what happens? Because sometimes people in such topics, they want to hear completely without, disturbing. Okay, very good, Bikram, very good. Wonderful. I like this. But इसमें और एक कंडीशन लगाना पड़ेगा. Because problem, okay, hope up to here it's clear. See, if it is clear, please let me know so that I'll continue remaining story, sir. Wonderful. Now, this is a recurrence relation. See, of course, writing recurrence relation means completed, but whenever you write recurrence relation, you should keep one thing in mind. What is that? Can anyone tell me? Yes, very good. Thank you, Bikram Sahi. Nice response. Okay, very good. What is the thing we should keep in mind whenever? Yes, very good, Vishal Garje. Okay, Vishal I'll call. Okay, very good. Now, what is the condition we should keep in mind? Base condition. Base condition हमेशा याद रखना है. Recurrence relation लिखे तो base condition. Because आप recurrence relation लिखेंगे without base condition, अगर आप उसके function लिखेंगे, if you execute the code, your code will run forever and ever and forever. Infinite loop में चले जाएगा, आपका सिस्टम भी क्रैश हो सकता है. Be careful with recursions or recursive functions. Okay, you have to be careful with your recursive functions. They are the dangerous fellows. Okay, see, once you write the recursion or recursive formula or recurrence relation, writing the recursive function is very simple, but please keep base condition in mind. So what is base condition, sir? We already seen one step, one way, two steps. How many ways you can climb? 2 ways. We already done that here. And I asked this question. One step, one way, two steps, two way, then 3 steps कितने ways में होगा? How many ways you can climb 3 steps? अभी तो recurrence relation से answer जल्दी कर सकते हैं, because what is an-1 for, what is an formula? Sorry, an formula. An का formula an-1 plus an-2 है. आपको a3 चाहिए. a3 क्या होगा? a3 minus 1, that is a2, a3 minus 2, that is a1. a1 ready है, a2 very ready है. दोनों को ऐड करो. a2 कितना? 2 plus 1 कितना होगा? 3. डायरेक्टली आंसर 3। अगर आप चाहे तो ऐसा भी चेक कर सकते हैं, व्हाट आर द 3 ways he can climb। ओके, व्हाट आर द 3 ways, लेट अस सी द 3 ways। अच्छा लगेगा। देखो ये एक वे है, विदाउट स्किपिंग, एक वे, फर्स्ट वे। कलर्स चेंज करूंगा सो दैट आपको पता चलेगा व्हाट आर द 3 ways। दूसरा वे होगा, ऐसा शुरू करेगा, ओके, विथ स्किप, और नहीं तो पहले ऐसे ही करेंगे, लेट अस सी दिस। ऐसा शुरू करेगा विदाउट स्किपिंग द स्टेप, बट नाउ ही स्किप द स्टेप, ये दूसरा वे है। अब तीसरा वे क्या होगा, और एक कलर रेड यूज करेंगे। ये पहले स्किप करेगा बट बाद में स्किप करने की चांस ही नहीं है उसको, बस ऐसे ही जाना है। वो 3 वे से, बट विदाउट राइटिंग, without doing this, I answered already, 3 already answered. That is what recursion will do. You just need to write the recurrence formula that will take care of the solution. Of course, we can write direct solutions also. Later we learn, okay, solving recurrence relation is different story. Generally what I see is, whenever people talk about this recurrences, they combine everything. They want to learn recurrence relation, they want to learn how to solve recurrence relation, they combine everything. If you combine all these, you can never learn recurrence formulas or recursive ideas, my dear friends. If you want to think recursively, always stop here first. Up to here you learn how to express problem in terms of subproblem. How to express problem in terms of subproblem. Solving recurrence relation, one more very interesting topic hai. There are many methods, like the very famous, substitution method people call it, but generally the good name for that is iterative method. Iterative method होता है, and अगर वो linear recurrence relation है तो linear recurrence relation solving के लिए हमारे पास एक characteristic equation method होता है, ओके, एंड रिकर्शन ट्री मेथड होता है। अगर वो डिफरेंट टाइप ऑफ डिवाइड एंड कॉन्कर रिकरेंस रिलेशंस और डिफरेंट टाइप ऑफ रिकरेंस रिलेशन होता है तो रिकर्शन ट्री मेथड होता है। सो दैट डिफरेंट मेथड्स फॉर सॉल्विंग दिस, एंड फॉर अ पर्टिकुलर टाइप ऑफ रिकरेंस रिलेशन वी आल्सो हैव फेमस मास्टर थ्योरम। फॉर पर्टिकुलर टाइप ऑफ डिवाइड एंड कॉन्कर रिकरेंस रिलेशन वी कैन यूज मास्टर थ्योरम, वेरिएंट्स ऑफ मास्टर, ये सब सॉल्यूशंस है, वो दूसरा स्टेज है। But when you are learning only recurrence relation, just learn how to write problem in terms of subproblem. Don't worry about solution. This is the most dangerous. Sir, can we draw the tree for this solution? Yeah, draw कर सकते हो अभी इधर है ना, आपको इधर 3 करके भी सॉल्व कर सकते हैं। That is method of solving, sir. That is method of solving. A3 क्या है? A3 क्या होगा? A3 will call what? A2, A1. इन दोनों को कॉल करके ऐड करेगा। Okay, Rajkumar, once again tell me when you started. I do not know, so can you tell me where you want me to start, from where you want me to start, because already it is a class which is taken 30 minutes time. Okay, Manoj Kumar is writing something and he deleted. Once again tell Rajkumar, can you, आप बोल सकते हो मुझे? Can you tell me where is the point you started? Because suppose ये problem आपको समझ में नहीं, I mean you started in between, next problem फिर से समझने की कोशिश करो, because every problem in recursion is like a new idea. How you can see problem in terms of sub problem. Okay, so time permits मैं एक बार फिर से repeat कर दूंगा, because this is one of the interesting problem, because I completed this. Okay, अभी you know he is asking, Vishal Garje is asking, you teached math superb sir, thank you. Okay, thank you Manoj Kumar, thank you very much. ये भी अच्छा पढ़ाने की कोशिश ही होगा. For every subject I try to do the same justice and I try to do from very basics. That is my motto. Okay, I always take very basic concepts which people do mistakes. Okay, thank you for that. Yeah, Rajkumar, I'll come again. Just wait for a while, because next problem अभी शुरू करने वाला हूँ, वो समझने के बाद ये फिर से देखो, आपको समझ में आ जाएगा. But any particular doubt है तो आप पूछ लीजिएगा, I answer. So before that let me complete Vishal Garjes. ये होगा, but A2 is base condition. देखो ये base condition है, आप base condition reach करें तो A2 क्या होगा? A2 वैल्यू क्या होगा? 2 होगा. So ये 2 रिटर्न करेगा और ये A1 कितना रिटर्न करेगा? 1 रिटर्न करेगा. और इन दोनों का सम एक्चुअली रिटर्न, नॉट दीज टू रिटर्न सेपरेटली, इन दोनों का सम जो है वो रिटर्न करेगा. दैट इज 2 + 1, दैट इज 3 इज रिटर्न हियर. टुमारो वी वर्क ऑन दिस. recursive function दिए तो उसका solution, that is what is the value of that, we try to understand. There you see this tree method in more detailed manner. Tomorrow and after tomorrow is that work. I'm going to take recursive functions or recursive formulae and I ask what is a10 value. And there we learn all these tricks, all these ideas we learn in more detailed manner. So please do attend tomorrow and after tomorrow class. It would be very, very useful even for your C programming. That is the idea which you are going to, that generally in GATE examination, they give a C code and they ask what is the particular value. In that it would be very, very useful, sir. Oh, very good, Rajkumar. Very good, very good. Very nice. Okay, Vishal Garje, hope I answered your question, dear. आपको समझ में आया है ये? Good. ये है इसका आइडिया. Of course, if you want A4 ना, A4 क्या करता है? A4 क्या करता है? A4 will call what? A3, A2 को कॉल करता है. A2 तो बेस है, यानी बेस कंडीशन रीच हो गया आपने. So it will not call anything. Directly वो value return कर देता है. A3 क्या करता है? It will call A2 and A1. A2 returns the value. A2 का value कितना है? 2 है, वो रिटर्न कर देता है. A1 का वैल्यू कितना है? 1 है, वो रिटर्न करता है. 2 + 1 कितना? 3. सो ये दोनों, दैट इज A3, व्हाट इज द वैल्यू रिटर्न सर? द सम विल बी रिटर्न, दैट इज 2 + 1 3 इज रिटर्न. A2 का वैल्यू 2 है, दिस इज A2 रिटर्न्स व्हाट? 2. अभी 3 + 2 क्या होगा? 5. 5 इज रिटर्न, सो A4 वैल्यू 5 होगा. ऐसा रिकर्शन ट्री से आप समझ सकते हैं. दिस वी ट्राई टू डू टुमारो सर and after tomorrow. I'll try to take up very, very interesting. Some of the GATE questions also we'll discuss here. Am I clear? That part, that is also kind of recursive thinking only. That is, we should know what is winding phase and what is unwinding phase. वो सब हम कल समझने की कोशिश करेंगे. Today, the idea is only writing recursion. Problem in terms of sub-problems. Same sub-problems. Problem in terms of same sub-problems. समझ में आया है? गुड. अभी और एक प्रॉब्लम लेंगे. ये बहुत बहुत इंपॉर्टेंट प्रॉब्लम है. मेनी वर्जन्स ऑफ द सेम प्रॉब्लम वेर आस्क्ड इन गेट एग्जामिनेशन. दिस इज वन ऑफ द इंपॉर्टेंट प्रॉब्लम. एंड अगेन आई विल टेल यू हाउ पीपल जनरली सॉल्व दिस प्रॉब्लम फर्स्ट, देन विल सी रिकरेंस फॉर्म. दोनों देखेंगे. जनरली गेट में दिए तो रिकर्सिव थिंकिंग से नहीं जनरली सॉल्व कर सकते हैं, बट we'll also see how we can recursively solve this problem. That is how you can think. That is problem को सब problem की तरह कैसे देखेंगे वो भी समझेंगे. Because that is the main motto of this short-term course. Am I clear? See, in this short-term course totally, I am coming with 4 topics. Recurrence relation, yesterday and today I done it. Those who missed, please go back and see yesterday's video also. Tomorrow, day after tomorrow, I'll be working on recursive functions. As our friend asked, na, so how you write the formula or value of a particular recursive function. Okay, that we try to see tomorrow and after tomorrow. Then binary tree traversal, we try to understand the binary tree traversal. That is also based on recursion. Then one important dynamic programming problem, that is matrix chain multiplication, will be discussed on 6th day. That is 31st matrix chain multiplication I discuss, and that is the important question for GATE point of view. Those who attend this session completely can easily get at least 2 to 3 marks in GATE, sir. More than that also possible. If you know, because all these are very, very important for GATE point of view. Okay, so if you are preparing for GATE also, 2 to 3 marks are guaranteed with these ideas, and sometimes more also. Because for every topic there were 2 marks questions asked, so in that way 6 marks may be आ सकता है. Am I clear? So this is one of the important topic which I selected. Got it? Not only for GATE point of view, even if you are looking for problem solving in the future. Now look at this. Number of binary strings बोलते हैं, bit strings भी बोल सकते हैं. ये n क्या है? Number of, I simply write BS, sir. Binary strings of length n that do not have consecutive zeros. उसमें consecutive zeros नहीं रहना है. So not contain, मैं इसको बदल के लिखता हूँ because इतना बड़ा statement लिखना difficult हो जाएगा. Not containing pattern 0 0. पैटर्न भी लिख सकते हो या समझ में आए तो ऐसा लिख सकते हो. Because this is for our understanding, not for anyone. Am I clear? Not containing 0 0. Number of binary strings of length not containing 0 0. Okay, अभी A1 क्या होगा? How many binary strings of length 1 which do not contain 0 0? देखो बाइनरी स्ट्रिंग ऑफ लेंथ 1 क्या होगा सर? या तो 1 होगा या तो 0 होगा. इसमें तो 0 0 नहीं है. Even in this 0 0 is not there. Correct or not? Even in this 0 0 is not there. Even in this 0 0 is not there. So how many binary strings of length 1 do not contain consecutive zeros or do not contain the pattern 0 0? दोनों में. Both are not containing 0 0. So 2 are there. How many such fellows are there? 2 are there. Got it? अब ये 2 क्या होगा? Very good, Vishal. Thank you. So please Vishal or Bikram Sahi, okay, or Manoj Kumar, okay, even if you are a mathematics student, non-computer science student, this is a general problem solving methodology, my dear friends. Okay, computer science में यही specialty है, especially data structures algorithm courses, okay, या आप discrete mathematics लिए तो they are general mathematical concepts or general logical concepts है. Anyone can understand any of these topics. That is the beauty of these courses. Am I clear? Of course, if you are not a very serious computer science student or not interested in, problem solving or competitive examinations or coding examination, it may not be that useful, but anyone, not necessarily computer science, any branch student can attend this. Okay? Because it will help you in understanding the logical ideas. Your analytical skills बढ़ेगा, ये data structures और algorithm course कभी भी पढ़ेंगे तो. You take any of the coding examination, the most important topics are data structures and algorithm together with a particular programming language. Bas. Okay? Very good, Bikram. Then it is very, very, very essential for you, for us. Okay? Now, A2 क्या होगा? Anyone can answer this, sir? Bikram, Vishal, or Manoj, or anyone? Anyone want to answer this? A2 क्या होगा? How many binary strings of length 2 do not contain 0 0? देखो एक सिंपल टेक्निक है बाइनरी स्ट्रिंग्स ऑफ लेंथ 2 लिखने के लिए. आप ना राइट साइड बाइनरी स्ट्रिंग्स ऑफ लेंथ 2 4 होंगे. आप इधर से शुरू करेंगे ऐसे 0 1 0 1, अल्टरनेटिवली 0 1 लिखेंगे. देन इन द नेक्स्ट कॉलम double the number of zeros and double the number of ones. Yani 2 zeros. Very good, Sidhu. Wow. Good, Sidhu. Wonderful. On the target. Double the number of zeros and double the number of ones. अभी पहले 1 0 1 1 है, अभी 2 zeros 2 ones होगा. See here, I do not know the level of different students. So anything I am trying to explain from very, very basic level, my dear friends. See, if it is a continuous class, things would be in a different manner, but I am trying to target any student with very basic knowledge can understand this. Not necessarily computer science students. Computer science student को तो समझना ही है. Okay, वो कैसे भी समझेंगे. Non-computer science student at any level can also understand this. That is the idea, sir. Hopefully, I am doing that. अभी देखिए इसमें ना except this 0 0, total 4 है. Remaining all do not contain consecutive zeros. So कितने हैं? 3. And that is what exactly our friend Sidhu told. Sidhu exactly वही आंसर दिया है 3. Perfect. Okay. So you can continue the story. आप चाहे तो ये 3 भी लिख सकते हो. But again, homework नहीं, थोड़ी देर बाद मैं लिखूंगा इसका आंसर. This is how we can write down and check 0 0 कहाँ पे नहीं है, वो सब चेक करके लिख सकते हैं. But we are learning how to think recursively. We are learning how to think recursively. So इसके लिए क्या करना पड़ेगा? देखिए, ध्यान से देखिएगा. An is number of binary strings of length n not containing pattern 0 0. So an minus 1 क्या होगा? An minus 1 क्या होगा? the number of binary strings of length n minus 1 not containing 0 0. an minus 2 क्या होगा? number of binary strings of length n minus 2 not containing 0 0. ओके, अब देखिएगा ध्यान से, very important. Now look here, I want to know how many binary strings of length n are there. Okay, now I ask you one question. Any binary string of length n start with what? Starting position में क्या हो सकता है? What can be the starting position? यानी फर्स्ट बिट पोजीशन क्या हो सकता है? What can be the first bit position? How it can start? Previous problem में भी वही बोले थे. How you can start? Climbing and step. How you can start? You can start without skipping or with skipping. इधर भी वही क्वेश्चन पूछ रहा हूं. अगर आप ये ठीक से समझेंगे, डायनामिक प्रोग्रामिंग के पूरे रिकर्शंस आप ठीक से समझ पाएंगे. बिकॉज द एंटायर डायनामिक प्रोग्रामिंग, इधर एक पैरामीटर है, डायनामिक प्रोग्रामिंग वाले रिकर्शन में 2 पैरामीटर हो सकते हैं. दैट इफ यू वांट टू अंडरस्टैंड, ये बेसिक स्टेप है. See, many people I see that they solve dynamic programming problems, they know recurrence relation, but they never know how you get the recurrence relation. And if you do not know how you get the recurrence relation, you can only solve the problems which are given to you so far. New problems आप solve नहीं कर पाएंगे. You know how to solve the problem. See, how to solve the problem is simple. But if you can write recurrence relation, you can create new recurrence relations. That idea we should learn. Got it? Oh, very good, Sidhu. 0 or 1. It should either start with 0, as my friend Sidhu said. It should start with, okay, start with 0, या start with 1. मैं क्या करता हूं, पहले start with 1 लेता हूं, बाद में start with 0 लेता हूं. कोई भी ऑर्डर चलेगा ना? It's not like पहले 0 ही लिखना है, ऐसा कुछ नहीं. Okay, wonderful, very good, Sidhu. अब देखिएगा, the length is n, but it is starting with 1. इधर length is n, ये starting with 0 हो रहा है. अब ध्यान से देखिएगा, please see this carefully. Now it is starting with 1. Remaining problem क्या है? Remaining problem is binary string of length n minus 1 not containing 0 0. Now the point to be understood and point to be verified is, ये n minus 1 string जो है उसमें 0 0 नहीं है, बट उसको 1 अटैच करने से 0 0 पैटर्न आएगा या नहीं, वो चेक करना पड़ेगा आपको. क्योंकि ये 1 अटैच करने से 0 0 पैटर्न आए तो n लेंथ में आपको 0 0 पैटर्न आ जाएगा. ओके, देखो ये n-1 स्ट्रिंग में 0 0 नहीं है, ये 1 अटैच करने से आपको 0 0 मिल सकता है या नहीं. इसके लिए वी जस्ट चेक, ये 2 पोजीशंस क्या हो सकता है, बिकॉज इसमें 0 0 नहीं है ना, इसमें n-1 में ये हो सकता है 0 1 या 1 0 या 1 1. 0 0 तो नहीं रहेगा. अगर आप 1 अपेंड करेंगे तो 1 अपेंड करेंगे तो या अटैच करेंगे तो 0 0 पैटर्न नहीं आएगा ना, नहीं आएगा. सो इट कैन स्टार्ट विथ 1, देन रिमेनिंग प्रॉब्लम कैन बी बाइनरी स्ट्रिंग ऑफ लेंथ n-1 नॉट कंटेनिंग 0 0 चलेगा. ओके, सो इट कैन स्टार्ट विथ 1 इन वन वे, फॉलोड बाय रिमेनिंग सब प्रॉब्लम क्या होगा, बाइनरी स्ट्रिंग ऑफ लेंथ n-1, दैट इज an-1. होप यू अंडरस्टैंड, समझ में आया है. अब देखिएगा, अगर ये 0 से शुरू हुआ तो दिक्कत क्या है, व्हाट इज द प्रॉब्लम. सपोज इफ इट इज स्टार्टिंग विथ 0, if it is starting with 0, can I take the remaining problem as binary string of length n-1 not containing 0 0? ले सकता हूं. बाइनरी स्ट्रिंग ऑफ लेंथ n-1 नॉट कंटेनिंग 0 ले सकता हूं, 0 0. ध्यान से देखिएगा. सी, ये n-1 स्ट्रिंग में 0 0 नहीं है, सो या तो ये 1 0 होगा, या तो 1 1 होगा, या तो 0 1 होगा। ये n-1 स्ट्रिंग में 0 0 नहीं है, बट इफ यू अपेंड 0 0 1 नॉट ए प्रॉब्लम, 0 1 नॉट ए प्रॉब्लम, बट 0 0 n स्ट्रिंग में 0 0 आ जाएगा। सो इट इज नॉट जस्ट बाइनरी स्ट्रिंग ऑफ लेंथ नॉट कंटेनिंग 0 0, some extra condition also we need to be added, and और क्या कंडीशन लगाना है, ये 0 भी 0 से स्टार्ट नहीं होना है, सो इट शुड स्टार्ट विथ 1 एंड स्टार्टिंग विथ 1 होना चाहिए। तब आपको ये n-1 स्ट्रिंग में 0 0 नहीं है तो 1 ये 0 अटैच करने से और अपेंड करने से बाइनरी स्ट्रिंग ऑफ लेंथ n में भी 0 0 नहीं आएगा, बिकॉज n में भी 0 0 नहीं आना है, n-1 में भी 0 0 नहीं आना है। That is our aim. So ये binary string of length n-1 not containing 0 0 and starting with 1 means, अब ध्यान से देखिएगा, मैं इसको फिर से लिख रहा हूं, ये 0 है but it is length n-1 starting with 1 and not containing 0 means इधर 1 होना चाहिए, ये फिक्स है, ये फिक्स है, 0 फिक्स because you are it is starting with 0, ये फिक्स है, और ये भी फिक्स करना पड़ेगा। क्यों? बिकॉज इधर 0 है तो 0 0 मिल जाएगा, हमें नहीं चाहिए, वी डोंट वांट 0 0 पैटर्न। सो अब रिमाइनिंग प्रॉब्लम क्या होना चाहिए, सो इट हैज टू स्टार्ट विथ 1 मींस इट इज बाइनरी स्ट्रिंग ऑफ लेंथ n-1 नॉट कंटेनिंग 0 0 पैटर्न एंड स्टार्टिंग विथ 1। इसे और किस तरह से बोल सकते हैं, इन व्हाट वे वी कैन एक्सप्रेस दिस, बाइनरी स्ट्रिंग ऑफ लेंथ n-1 स्टार्टिंग विथ 1 को हम कैसे बोल सकते हैं, 1 एंड रिमेनिंग पार्ट क्या है, इट इज बाइनरी स्ट्रिंग ऑफ लेंथ n-2 नॉट कंटेनिंग 0 0, नॉट कंटेनिंग 0 0, यानी ये 0 1 कितने वे से शुरू कर सकते हैं, इट कैन स्टार्ट विद 0 in 1 0 1 इन हाउ मेनी वेज, 1 वे, 0 1 फिक्स है ना, एक ही वे होगा, बाकी प्रॉब्लम कितने वेज में सॉल्व हो सकता है, because you have to complete remaining n-2 string, that is you have to find number of binary strings of length n-2 not containing 0 0, वो an-2 टेक केयर करेगा, आपका प्रॉब्लम नहीं है, बिकॉज आपने प्रॉब्लम को सब प्रॉब्लम के रूप में लिख दिया है, द सब प्रॉब्लम विल टेक केयर ऑफ दैट, you are not the responsible person, you could able to express problem in terms of sub problem अपने सब प्रॉब्लम की टर्म में लिख के गए, it will write in its sub problem, that will be written in its sub problem, like that the recursion works. But when you are writing recurrence relation, your work is expressing problem in terms of sub problem, उधर आपका काम खत्म हो जाता है। Am I clear? That is where your work completes. Am I clear? So this would be an-2 my dear friends. So therefore an value क्या होगा, an-1 plus an-2 होगा। See, it looks like recurrence relation for the previous problem, but उसमें और इसमें अंतर है, फर्क है, क्योंकि उधर प्रीवियस प्रॉब्लम में ये 1 है, ये 2 है, बट हियर a1 is 2, ये 2 कितना है, 3 है। सो रिकरेंस रिलेशन में भी सेम, बट बिकॉज ऑफ द बेस कंडीशन द आंसर्स विल डिफर, सो दैट इज द इंपॉर्टेंस ऑफ बेस कंडीशंस। अब मैंने एक क्वेश्चन पूछा था आपको, A3 का आंसर क्या है, व्हाट इज आंसर फॉर A3, व्हाट इज आंसर फॉर A3, ओके फाइन। A3 का आंसर क्या होगा, बिकॉज an इज इक्वल टू an-1 प्लस an-2, A3 का आंसर A2 प्लस A1 होगा, A2 2 था, सॉरी A2 3 था एंड A1 2 था, 3 + 2 5 हो जाएगा। अगर आप ऐसा नहीं सॉल्व करना ही है तो व्हाट यू हैव टू डू, A3 मींस फाइंड बाइनरी स्ट्रिंग्स ऑफ लेंथ 3, कितने होंगे, 0 1 0 1 0 1 0 1, डबल द नंबर ऑफ जीरोस, डबल द नंबर ऑफ वंस, again double the number of zeros, very good Sidhu, wonderful, very good, beautiful, double the number of ones, again double the number of zeros, that is 4 zeros and 4 ones। अभी इसमें 0 0 पैटर्न in how many we do not have 0 0 pattern? This is ruled out because 0 0 hai isme. Even this is ruled out. Even this is ruled out. These three are out. Therefore, what is the correct answer? A3 is 5. 5 members. 1, 2, 3, 4, 5. ऐसा भी check कर सकते हैं. Now, in GATE examination, if the same problem is given, you can try like A1, A2, A3, find out करके इसमें substitute करके check कर सकते हैं. In each of the options, you can substitute and verify. For example, according to option A, A3 क्या होगा? A2 plus 2A1 होगा. A1, A2 तो ready है ना? So A2 कितना है? A2 is 3, 2 into 2, 4, 7 होगा. Which is wrong because A3 5 है, ये option गलत है. Wrong option. फिर इधर भी चेक करेंगे A3 क्या होगा 2 into A2 A2 कितना 3 plus A1 2 so 2 3 6 plus 2 कितना 8 ये ऑप्शन भी गलत ही है ओके सो ये भी गलत आंसर है इधर क्या होगा A3 A2 3 plus 2 5 and it is the correct answer but you have to check D option also sometimes more than 2 options may be correct तब आपको A4 भी फाइंड आउट करके वो भी चेक करना पड़ता है sometimes it happens okay instead of that if you write the recurrence relation you will never do mistake my dear friends recurrence relation लिखेंगे तो आपका आंसर perfectly correct आ जाएगा गलती कभी नहीं करेंगे आप so this is about how to think recursively in that we are talking about recurrence relations so yesterday and today I discussed some beautiful problems. There are so many other beautiful problems, sir. We'll be discussing later on also. Okay, in the class also we discuss some more problems, regular classes. See, my classes, some people ask me like where to get the classes. Okay, whether you are teaching, you know, in paid courses. See, already our paid recorded classes are available under BYJU'S Exam Prep app. Okay. Learn with video lessons. I recorded 4 subjects, not 4, 5. Actually, C and data structures I done separately. So totally 5 subjects I recorded. Okay, I'm expert in all the 5 subjects and very well known for the subjects. And you can find these recorded versions. I request all of you to download the BYJU'S Exam Prep app and under the category Learn with Video Lessons, you can find the visualized animated content. So some of those animations or visualizations I shown here also in this PPT. So we created such content for you, my dear friends, and please write your feedback. Okay, and please keep watching. Tomorrow again I'm coming live at 8 p.m. Please note 8 p.m. tomorrow. Okay, tomorrow and day after tomorrow, recursive function part 1 and recursive function part 2. Okay, thoda C functions use karenge because C language is the basic programming language used in GATE programming. So I'll be using C codes, my dear friends. Okay, once you learn C programming, any other programming language becomes very, very simple, my dear friend, for learning. Okay, because C programming is difficult, but in GATE, that is the language used. Okay, so we see recursive functions. Okay, and a function is given. Generally this type of questions they ask in GATE examination. What is the output? That type of questions we'll see tomorrow and day after tomorrow, my dear friends. Then this is, I think today is 27, right? 28th is this, and 29th, 28 and 29 we discuss this recursive function part 1, part 2. On 30th we talk about binary tree traversals. I'll give you the shortcuts also for this binary tree traversal. And 31st we talk about matrix chain multiplication. And it is dynamic programming, my dear friends. I'll give you the recurrence relation and how to solve the dynamic programming problem. One of the important questions for GATE point of view. This is also for GATE point of view, very important. This is also for GATE point of view, very important. Even recurrence relations which I done today and yesterday, they are very important for GATE point of view. And you can see all these topics were asked in GATE examination for 2 to 2 marks. Okay, if you are lucky, 6 marks you can score from this, my dear friends. Okay, so this is about today's class, how to think recursively. Hope I could able to give some good questions to you. Hope you all understand the idea. See, later on also, if you are seeing, if you get any doubts, okay, any mistakes you identify, you can please comment, my dear friends. That's all for today. Keep watching, subscribe to our YouTube channel, okay, and also download BYJU'S Exam Prep app to see more. Thank you.